Hello students, how are you? From today onwards we'll study in a series of lectures in greater details about the physics behind light, or you say the physics of light in fact. What is light? Do you have any solid answer for that? What in fact is light? It seems like we know something about light. We have seen the blue seas and the oceans, the blue lakes, the dark green forests, and the blue skies and the multicolored rainbows, the red roses and the yellowish sunflowers. So many colors are there in our real life. And we get to see the nature around. We enjoy the beautiful, colorful nature around with these two beautiful eyes gifted by nature. So it means that if I have two healthy eyes and the presence of light around, as you can see me right now in this video, can make us to see all the colorful, beautiful nature around us. But what exactly is light? It was a tough question in the past, and still it is, as scientists agree for that. Many optical devices like cameras, telescopes, the eyeglasses, even the microscopes are built on the properties of light. You can easily see that I'm wearing lenses to make my vision clear. So definitely there is something going around with respect to this piece of glass, the light around, and my eyes, which makes me very comfortable in viewing the things around. What exactly is light then? In physics, the study of light comes under a very separate branch, which is called as optics. So this question is most famously answered in the past by the great Sir Isaac Newton, who proposed that light consists and propagates as a stream of particles, which he called as corpuscles. But later on, Christian Huygens put forward another beautiful theory about light and its propagation. He called it as a wave. And Galileo also did try to measure the speed of this light, pretty much unsuccessfully. But the real research was put in, and the real answer about the nature of light was put forward by the genius of British scientist James Clerk Maxwell, and path-breaking research done by Heinrich Rudolf Hertz, whose experiments by the year 1887, if I'm not wrong, conclusively laid out an answer to this. And from that time onwards, we call light as an electromagnetic radiation, a combination of electrical fields and magnetic fields, which can self-propagate even in vacuum, solids, liquids, and gases. If I have to compare with the sound waves almost can do it in solids, liquids, and gases, but not in vacuum. So there is a difference in these two types of waves, electromagnetic radiations and the sound waves. But the wave picture of light is not the whole story about it. The several effects associated with emission and absorption of light reveal a particle aspect. In that, the energy carried by the light waves is packaged in discrete bundles called photons or quantum. These apparently contradictory wave and particle properties have been reconciled since 1930 with the development of quantum electrodynamics, which is right now well beyond our syllabus. Quantum electrodynamics. So the fundamental sources of all the electromagnetic radiation are electrical charges which are in accelerated motion. All bodies emit electromagnetic radiation as a result of thermal motion of their molecules. This radiation is called as thermal radiation is a mixture of different wavelengths. At sufficiently high temperatures, all matter emits enough visible light to be self-luminous. A very hot body appears red hot, or white hot as we say. So light seems to be playing a dual role. Sometimes it behaves like a stream of particles, which was beautifully exploited by the great Albert Einstein experiment on photoelectric effect. But at the same time, if you have to really understand the phenomena of dispersion or diffraction, interference and polarization of light, the particle theory fails in it. And then we have to switch on to the wave theory of light, which we will discuss in our future lectures coming up. So, on this first lecture of the series, here I ask you and leave you to discuss and think about what is light and how it helps us to see the things around. Thank you. Have a great day ahead.